Hello students, in this video we will continue with the revision and we will cover the questions from the chapter circles and areas related to circles. First question, this is a case study given in the previous year. So we will try solving it. The discus throw is an event in which an athlete attempts to throw a discus. The athlete spins anti-clockwise around 1.5 times through the circle, then releases the throw. When released, the discus travels along tangent to the circular spin orbit. Okay. See, till here we don't have to do anything, and from here the actual question starts. In the given figure, AB is one such tangent. See, the AB is the tangent to a circle of radius 75 centimeters. Radius is given as 75 centimeters. Point O is the center of the circle and angle ABO is 30 degrees. Angle ABO is 30 degrees. PQ is parallel to OA. Okay. Here PQ is parallel to OA. Okay. This OA is the radius and AB is the tangent. Okay. Now what do we know here? Radius is perpendicular to tangent. Right. So this angle is 90 degrees. Angle OAB is 90 degrees. Okay. Now based on the above information, find the length of the AB. Find the length of AB. We have to find the length of the tangent. Okay. The first one, see, we have here angle 30 degrees. Okay. And we have the radius, it is 75 centimeters. We have to find AB. Okay. We can use the trigonometric ratios to find the answer. See, for angle 30, OA is opposite side. Okay. And AB is the adjacent side. Right. So we will use tan theta. Tan 30 is equal to opposite side, it is OA, divided by adjacent side, it is AB. Okay. Tan 30 is 1 by root 3 is equal to OA is 75 divided by AB. So here AB is equal to 75 root 3 centimeters. Okay. Second one, find the length of OB. We have to find the length of OB. This. See, OB is hypotenuse for this right angle triangle. We can use the Pythagoras theorem or we can use again the trigonometric ratio to find OB length. Okay. Here we have opposite side. For angle 30, we have opposite side and we need hypotenuse. Okay. So we will use sin theta. Sin 30 is equal to opposite side. It is OA divided by OB, hypotenuse. Sin 30 is 1 by 2 is equal to OA 75 divided by OB. Okay, here OB is equal to 75 into 2. It is 150 centimeters. Okay, this OB is 150 centimeters. Next one, find the length of AP or find the length of PQ. Okay, see, AP is this one. What we have to find the length of AP or PQ. Okay, we will draw the triangle here again. See, this is 90 degrees, this is O, this is A, this is B, okay, PQ, this is PQ, this is P, this is Q, radius is 75 centimeters, OQ is also radius, it is 75 centimeters and the angle given is 30 degrees, okay, PQ is parallel to OA. We have to find AB or we have to find PQ, okay. And we got OB as 150 centimeters and AB as 75 root 3 centimeters. Okay. AB is 75 root 3 centimeters and OB is 150 centimeters. Okay. See, here we have a triangle. Okay. And this line PQ. PQ is parallel to BC. Okay. This is A. PQ is parallel to BC and PQ is intersecting AB and AC. Okay. Now what property or theorem can we apply here? We can apply Thales theorem or basic proportionality theorem. What is this theorem? If a line is drawn parallel to another line. Okay. So this line intersects the other two sides of a triangle in same ratio. That is AP by PB is equal to AQ by QC. Okay. The ratios will be same. AP by PB is equal to AQ by QC. Okay. See, in this given figure, PQ is parallel to OA. So, PQ divides BO and AB in same ratios. That is, BQ divided by QO is equal to BP divided by PA. Right. Here, BQ is what? BO is 150 and QO is 75. BQ will be 150 minus 75. This will also be 75. Okay. BQ is 75 divided by QO is 75 is equal to BP divided by PA. Okay. Here 75 and 75 will be cancelled. We get here PA is equal to BP. Okay. Here PA is equal to BP. Okay. We will assume this as X. Okay. So here AB is equal to AP plus BP. Okay. It is X plus X. AB is 75 root 3. So here X is equal to 75 root 3 divided by 2. Here we got AP as 75 root 3 divided by 2. This is AP value. And we have to find QP value. Here OA is parallel to PQ. Right? So angle OAP is equal to angle QPB. Okay. So angle QPB will be 90 degrees. Okay. This will be perpendicular. Okay. Now we will use the trigonometric ratios. We have hypotenuse side BQ and we need opposite side. We will use sine theta. Sine 30 is equal to opposite side QP divided by hypotenuse. It is QB. Okay. Sine 30 is 1 by 2 is equal to QP divided by QB is 75. So here QP is equal to 75 divided by 2. It is 37.5 centimeters. Okay. We got here QP value as 37.5 centimeters and AP value as 75 root 3 by 2 centimeters. Okay. Next one. In the given figure, PQ is tangent to the circle centered at O. PQ is tangent and the center is O. If angle AOB, this angle is 95 degrees. Okay. Then find the measure of angle ABQ. ABQ, we have to find this angle. Okay. We have to find this angle ABQ. Okay. See here OA and OB, these two are radius. So these both are equal. OA is equal to OB. So this forms an isosceles triangle. So angles opposite to equal sides are equal. Okay. So we will assume this as X. Okay. In triangle AOB, angle AOB plus angle OAB plus X is equal to 180 degrees. Okay. AOB is what? 95 plus 2X is equal to 180 degrees. So here we have 2X is equal to 180 minus 95. So 2X is equal to 85. So here X is equal to 85 divided by 2. It is 42.5. Okay. See here X is equal to 42.5. Okay. OB is radius and PQ is the tangent. Radius is perpendicular to tangent. So angle X plus angle ABQ is equal to 90 degrees. So angle ABQ is equal to 90 degrees minus 42.5. It is 47.5. First option. Next one. In the given figure, a circle is inscribed in a quadrilateral ABCD, in which angle B is 90 degrees. Angle B is 90 degrees. If AD is 17 centimeters, AD is 17 centimeters, AB is 20 centimeters, AB is 20 centimeters, and DS is 3 centimeters. This DS is 3 centimeters. Then find the radius of the circle. Okay. Now, if you see this part, point D is an external point. Okay. And DR and DS, these both are tangents to the circle. Okay. So, the tangents drawn from an external point to the circle are equal. So, these two tangents are equal. So, DR will be 3 centimeters. DR will be 3 centimeters. If DR is 3 centimeters, then what is RA? It is 17 minus 3. It is 14 centimeters. Okay. Here RA is 14 centimeters. Okay. And DR is 3 centimeters. Okay. And if you see this part, point A is an external point and the tangents drawn from an external point are equal. So RA is equal to AQ. So RA is equal to AQ. It is 14 centimeters. AQ is 14 centimeters. So what is QB here? QB is 20 minus 14. It is 6 centimeters. QB is 6 centimeters. Right? So this OQ is radius and AB is tangent. Radius is perpendicular to tangent. So this angle is 90 degrees. And OP is radius, BC is tangent. So this angle is also 90 degrees. This forms a quadrilateral. OPBQ is a quadrilateral. And we will add all the angles. Angle QOP plus angle P, it is 90 degrees, plus angle B, 90 degrees, plus angle Q, it is 90 degrees, is equal to 360 degrees. So angle QOP is equal to 360 degrees minus 270. It is 90 degrees. See, this angle is also 90 degrees. And if you see this part, point B is an external point, right? So tangents drawn from an external point to the circle are same. So BQ is equal to BP. So BQ is equal to BP. It is 6 centimeters. Okay. And all angles are 90 degrees. What could the quadrilateral be? It is a square. Okay. If it is a square, all sides are equal. Then radius OP is equal to QB. So radius is equal to 6 centimeters. Okay. Next one. A chord of a circle of radius 14 centimeters subtends an angle 60 degrees at the center. This is a circle. Okay. The center is O. The chord of a circle. Okay. This is a chord. We will take it as AB. Okay. And the radius is 14 centimeters. Radius is 14 centimeters. This chord subtends an angle of 60 degrees. This is 60 degrees at the center. Okay. Find the area of the corresponding minor segment of the circle. Also find the area of the major segment of the circle. So we have to find the minor segment. See, this is the minor segment. Okay. And the rest of the circle is major segment. This full part is major segment. Okay. Now we have to find the area of the minor segment. How do we find the area of the minor segment? See, we have to find the area of the sector. Area of the sector AOB. Okay. And we have to subtract area of triangle from the area of sector. Then we will get area of the minor segment. This is area of minor segment. That is area of sector minus area of triangle. Okay. For that, first we have to find the area of the sector. How do we find the area of the sector? What is the area of this full circle? Area of the full circle is pi r square. Right. But the sector is a part of the circle. This sector is a part of the circle and it subtends an angle 60 degrees. So we will multiply here theta divided by 360 degrees. Okay, this is the area of sector. Here 22 by 7 into radius is 14 into 14 into theta is 60 degrees divided by 360. Okay, 60 into 6 here. 7 into 2, 14, 2 into 3. Okay, so it is 14 into 2 is 28, 28 into 11 is 308 divided by 3. This is the area of the sector. Okay, and how do we find the area of the triangle? See, the triangle, it subtends an angle 60 degrees. So this is 60 degrees. So the other two angles will also be 60 degrees, right? Other two angles will also be 60 degrees. Then it is an equilateral triangle and the side is 14 centimeters. Okay, what is the area of the equilateral triangle? It is root 3 by 4 into side square. Okay, it is root 3 by 4 into 14 into 14. Okay, here 2 into 2, 2 into 7. Again 2 into 7. Here we'll get 49 root 3. This is the area of the triangle. And how do we find the area of the minor segment? Area of the minor segment. Area of the minor segment is equal to area of the sector minus area of the triangle. Okay. What is the area of the sector? It is 308 divided by 3 minus 49 root 3. Okay. This is the area of the minor segment. Right. This is the area of the minor segment. And how do you find the area of the major segment? Okay. See, in the circle, one part, see this minor segment is this one. Okay. And the remaining part is what? Remaining part is whole circle area. Remaining part is whole circle area minus minor segment. Okay. By this we can get area of the major segment. Area of the full circle is what? It is pi r square minus of 308 divided by 3 minus 49 root 3. Okay. So here pi is 22 by 7 and radius is 14 into 14. Here 7 into 2. Okay. This minus 308 divided by 3 minus 49 root 3. Okay. Here you will get 14 into 4 is 56. 56 into 11 is 616. So the answer is 616 minus 308 divided by 3 plus 49 root 3. So here you can take LCM for these two terms. You will get 6 into 3 18, 4 here 18, 1848 minus 308 divided by 3 plus 49 root 3. Okay. Here you will get 1810 divided by 3 plus 49 root 3. This is the area of the major segment. Okay. Next question. In the given figure, a triangle ABC, okay, with angle B is 90 degrees. This angle B is 90 degrees. Taking AB as diameter, a circle has been drawn intersecting AC at point P. Okay. Prove that the tangent drawn at point P bisects BC. Okay. So we have to prove that the tangent PQ bisects BC. So we have to prove BQ is equal to QC. Okay. Here O is the center. Okay. We will join OP here. Okay. See, OA is equal to OP and the angles opposite to equal sides are equal. So we will take this angle as A and this angle will also be A, right? And we will join BP. Okay. See here AB is the diameter and angle APB. This angle APB will be 90 degrees because angle in a semicircle is 90 degrees. So angle APB is equal to 90 degrees. Okay. If angle APO is A, then angle OPB. Then this angle OPB. This will be what? It is 90 degrees minus A. Right? This will be 90 degrees minus A. Okay. And again, if you see in the triangle OPB, see OP is equal to OB. This both are radius. Okay. So the angles opposite to this equal sides are equal. So this angle OBP, the angle OBP will also be 90 degrees minus A. This angle will also be 90 degrees minus A. Okay. And angle OBQ, this is 90 degrees because OB is radius and BC is tangent. Radius is perpendicular to tangent and again angle B is 90 degrees. It is given in the question. Okay. So this angle will be what? PBQ. PBQ will be what? It is 90 degrees. So angle PBQ will be 90 degrees. Angle OBP, it is 90 minus A. You'll get here 90 minus 90 plus A. You'll get here A. Okay, this will be A. And again, if you see this part, OP is radius and PQ is tangent. Okay, radius is perpendicular to tangent. This will be 90 degrees. Angle OPQ will be 90 degrees. Okay. If angle OPB, this is 90 degrees minus A, then angle BPQ, this will be what? A. This will be A, right? Okay. So, if these two angles are equal in triangle BPQ, then the sides are equal. Sides opposite to these angles are equal. So, BQ is equal to QP. Okay, BQ is equal to QP. And for triangle BPQ, angle PQC. Angle PQC is external angle. Okay. So this angle will be what? Sum of two opposite interior angles. Okay. This will be A plus A. It is 2A. Okay. This angle will be 2A. Okay. If you see this part again, see angle APB. This is 90 degrees because angle in a semicircle is 90 degrees. So this angle will be what? It is 90 degrees because of linear pair. Okay. So angle BPC, this is 90 degrees. Okay. And if BPQ is A, then angle QPC will be what? 90 degrees minus A. This will be what? 90 minus A. Okay. So what is this angle? We will apply the angle sum property here. It is 90 degrees minus A plus 2A plus angle C is equal to 180 degrees. Okay. 90 plus A plus C is equal to 180 degrees. So angle C is equal to 90 degrees minus A. So angle C is equal to 90 degrees minus A. In triangle PQC, these two angles are equal. Angle P and angle C are equal. So the sides opposite to equal angles are equal. So BP. So QP is equal to QC. QP is equal to QC. So here we have proved BQ is equal to QP and here QP is equal to QC. So by using these two statements, we can say that BQ is equal to QC. Okay, that means PQ bisects BC. Okay, that's all for this video. If you like the video, please like, share and subscribe to the channel. Thanks for watching.